Hey guys, happy Friday. Just wanted to go over a few reminders before we get started here. One is that if you ever have any questions on the material or the assignments or expectations, please feel free to email me using your school email. I'm checking regularly. You should also be checking your school email regularly because teachers are going to give you reminders and feedback on assignments. Any questions you ask on the Edpuzzle at the end, I'm responding to, so check back for comments on those last questions because I am answering your questions. Another thing you want to check PowerSchool. Every day I'm updating your completed grade for completing the Edpuzzle and the classwork, so just keep an eye on that. All right, so circles again, day 2. Let's start with our do now. We're going to take a look at this circle here. I can see the diameter is 16 inches. We are going to find the area of the circle. I know area is equal to pi r squared, apple pi r2. Our diameter is 16, which must mean that our radius is 8. So we'll substitute in for r, our radius. That's the information we have. Square 8 is going to be 64, so we've got 64 pi, our answer in terms of pi, but we are going to round to the nearest hundredth, so 64 times pi, we get 201.0619298. Rounded to the nearest hundredth, that should give us 201.06, and our units were inches, so inches squared. Nice. Number 2, find the circumference of the circle. Leave answer in terms of pi. It doesn't get any easier than that. Circumference, cherry pie, delicious. Diameter is 16. Leave our answer in terms of pi. Just reorder it, commutative property here, and put the units on there. Inches, 16 pi inches. Love in terms of pi. Today we're going to continue on working with our area and circumference, but this time we might be given area and asked to solve for radius, diameter, or circumference. So just to set us up successfully for that, we're going to take a quick review of some of our perfect squares, squaring our numbers, and then also our square roots. So if we have something like 4 squared, we should remember that that really means 4 times itself 2 times, which gives us 16, a perfect square. Likewise, 7 squared tells us 7 times itself 2 times, which gives us 49. Knowing our perfect squares helps our knowledge of square roots, the opposite of squaring a number. So if we want to know what is the square root of 16, or what is the square root of 49, that square root symbol called the radical is really telling us in math what number times itself gives us 16. And as we can see from here, 4 times itself is 16. So square root of 16 is 4. Likewise, square root of 49, what number times itself is 49? 7 times itself is 49, so square root of 49 is 7. Okay, and we should have our perfect squares memorized up through 15. 15 squared is 225. This way, quick recall, we know, square root of 100, that's 10. Square root of 196 is 14. If you weren't sure about that, you could always use your calculator. We do have technology. You want to use your radical symbol. We're pushing that first, then putting in our number, 196, push equals, boom, 14. We're also going to wind up doing some square roots with variables underneath, what we call the radicand. Now, this tells us what number times itself gives us n squared. The only way to get n squared is to multiply n by itself. N times n is n squared. So the square root of n squared must be n. We're just undoing that squaring. So the square root cancels out that squaring. Okay. We're also going to see our squaring and our square rooting when solving equations. So we just want to go over the steps there. If we have the equation x squared plus 2 equals 27, we're solving for x, I'm first going to isolate the variable term by eliminating our constant, always getting rid of the constant first. So we'll subtract 2 from both sides, which leaves us with x squared equals 25. Now we have the variable term isolated, but we want to know just what is x. So we have to undo that squaring. We are going to take the square root of both sides. Square root of x squared is x. Square root of 25 is 5. So we wind up with x equals 5. Good. Let's do one more. I don't know why I wrote this so far in the bottom. 2x squared equals 27. To isolate our variable term, we're going to eliminate the coefficient. Divide both sides by 2. We get x squared is equal to 27 divided by 2, 13.5. And now we need to take the square root of both sides. Now this one I don't know, it's not a perfect square. Square root of x squared is still x. Now I need to use my technology, so I'm going to do square root of 13.5. We get a big long number. Let's round to the nearest tenth, which would be 3.7. Now let's apply our work to our booklet. We're on page 19, area and circumference of circles 2. So number 1. If a circle has an area of 289 pi units squared, then find its radius and its diameter. So we're kind of working backwards from what we did yesterday. We're talking about the area. So first thing, I'm going to write down our area formula. Area equals pi r squared. There's 2 variables, 2 unknowns, area and radius. This time we know the area. The area is 289 pi units. Notice how I'm including pi there in my circle. That's the area, 289 pi. That's what we're going to substitute in for A. So I'm just rewriting, substituting in 289 pi for A, our area, and setting it equal to pi r squared. Now our unknown is radius, and we're going to solve for that. Just like the previous example we did, we're going to isolate r. To do that, I have to divide by the coefficient. This time it's pi. So I'm going to divide both sides by pi, cancels out on the right. Divide both sides by pi. And the nice thing about our area being in terms of pi is we don't need our calculator. Pi divided by pi, that's going to cancel out and leave us with 289. Now we have to undo that squaring, so we take the square root of both sides, and you write the radical on both sides. Square root of r squared is just r. Now we need to do the square root of 289, and if you don't know that as a memorized perfect square, it is actually 17. So our radius is 17 units. Okay? And then from here we can quickly find our diameter, because we know our diameter is 2 times the radius. So our radius is 34 units. Once we've identified a radius or a diameter, the possibilities are endless, because from that we can even go and find our circumference, which we'll see later on in some classwork problems. Okay, so let's go to number 2 here, where we're stepping it up a notch. The circumference of the shaded sector of the circle below is 26.4 inches. Find the area of the shaded sector. Record your answer to the nearest tenth. So a couple of things we want to realize with this sector. One is that the sector is a quarter of the circle. And when we're talking about the circumference of the shaded sector, we're just talking about this part right here. That's it. Okay? So we have 2 options here. We can really work with the idea of the formula of circumference being a quarter of a circle, or we could figure out the full circumference first. And I think the easiest way to go about it is to figure out the full circumference. So if our circumference, our quarter of a circumference is 26.4, and I want the full thing, well, to take a quarter and make it a whole, I'm going to multiply by 4. So we'll do 26.4 times 4, and that gives us 105.6. So I'm just going to label my work here. That's the full circumference. Now that's easy to work with our circumference formula. Circumference equals pi times diameter. Since that's the full circumference, we can substitute that in for C. That's going to be our 105.6 equals pi times diameter. Now we'll solve for diameter. Divide both sides by pi. Now, this one wasn't in terms of pi. It gets a little messy here. So we have to do our calculator. 105.6 divided by pi. We're asked to round to the nearest tenth. So I'm going to leave our answer to the hundredth for now. So I'm going to say that that's 33.61 is our diameter. Okay. We're asked to find the area. To find area, we need to know the radius. So to go from diameter to radius, we're going to divide by 2. 33.61 divided by 2. And I'm going to round that to the nearest hundredth, 16.81. Okay. Now that we know the radius, we can use that to find the area. And again, I'm using the formula for area of the full circle, and then I'll worry about the sector afterwards. So we know the radius, area equals pi times 16.81 squared. So let's see, 16.81 squared. And again, I'll round to the nearest hundredth. Is going to be 282.6 pi. We'll multiply by pi and round to the nearest hundredth again. Oh no, I rounded to the nearest tenth. Oh well, let's see if I can go back and fix that for myself. That's okay. 0.58. Okay, so 282.58 times pi, and I'll round to the nearest hundredth like I said I would. I'll actually do it this time though. 887.75. And now again, that's the full circle. We want just the sector, which is a quarter. So to take a whole and get a quarter, we're going to divide by 4. So we'll do 887.75 divided by 4. Okay. Now this time we can round to the 10th because it's going to be our final answer. Hey, sorry, the video cut out there for a second and I was still talking and finished the problem before I realized it. So what we did was we multiplied by pi. We got 887.75, which was the area of the full circle. To find the sector, which is a quarter of the circle, we have to divide by 4, right? Splitting it into those 4 pieces. So we're doing 887.75 divided by 4, and I rounded to the nearest tenths because we're getting our final answer, 221.9. Then just formatting our final answer, 221.9 inches squared. Okay, so now you want to go on, do your classwork, page 20. It's only 1 page today. If you need more space, feel free to use an additional sheet of paper. Notice here at the bottom, we're talking about the area here. It is 2/3, 2/3. And we're talking about the circumference. We're talking about the outside part, not those internal parts. Make sure you go and you post your classwork on Padlet. This way I can see it. I'll put some comments on there for you guys. If you have any questions about the material or about how you're going to post your assignments, please, please, please feel free to email me. Hope you guys have a great weekend, and I'll talk to you guys on Monday. Bye.